In this question, we're asked to solve this system of two equations which has three unknowns using elementary row operations, or also called row reduction. And basically what we have here is two planes, and what we need to do is find the line that's contained in these two planes. So the solution, basically, which just happens to be a line, vector line. So what we're going to do, and actually this problem is a little bit unique, so I think you'll see that it was worthwhile to take a look, because it is a little bit different. So what I'm going to try and do is I'm going to eliminate this x here, try and create it 0 like we always do. To do that, I'll multiply this first equation by -3. So I'll have -3x plus 9y minus 6z equals -24. And then we'll have 3x minus 9y plus 2z equals 4. So if I solve this, you can see that this goes away. I'll have 0. This will go away. I'll have 0. This will be minus 4z, and this is minus 20. So this is a little bit unique because usually we just get rid of one of them. We just get rid of the x's first. But in this case, two variables went away. So we can continue. Z equals 5. So that tells us that the z value is always 5 of the line where these two planes meet, which is a little bit different. So now what I'm going to do is I'm going to plug our z value right here. So I have x minus 3y plus 10 equals 8, or x minus 3y is equal to minus 2. Now here's the part that's going to be a little bit new. What I'm going to do now is I'm going to let y equal t. And the reason I'm doing that is because the line that exists in these two planes, and I can even show it to you here, so the line that exists between these two planes, at some point, sometime there's many, infinitely many ways to represent this line. Even though there's only one line going through those two planes, there's many ways to represent this line. One way will be if we let the t value always equal the y value. It will happen. There's one time that the t value will be equal to the y value, and so we're going to start from there. So that's a little bit of a jump, I understand, but just let y is equal to t. Now I'll substitute t in for y here, so I get x minus 3t is equal to minus 2. I'll add 3t, so I get x equals minus 2 plus 3t. Okay, so there's the parametric form of our line. X equals this, y equals this, z equals that. I'll write it a little bit differently. I'll say r is equal to -2, 0, 5, so the x, y, z, plus t times the x will be 3, the y will be 1t, and there are no t's here, so that's 0. So this will be the vector form of our line.